In this video, we'll be learning how to solve a quadratic word problem that is written in vertex form. So let's dive in and take a look at this quadratic word problem. So here it says the equation below shows the height of a soccer ball, which is y. So you'll see here that I wrote this as h of x, but remember this can also be written as y. So there's kind of two things going on. It's talking about the height, but we can also write that as y equals if we want it to be a little bit more traditional equation looking. Then it says when a ball is kicked. So y is the height when a ball is kicked. The distance the ball travels horizontally is represented by x, which we can see is right here. And then the ball is kicked from a starting position that is on the ground, which means that its height is going to be at 0, 0. So just keeping that in mind as we draw our sketch later on. So here we can see that we have the equation y equals or h of x equals, and then we can see negative 0.025 times in parentheses x minus 20 squared plus 10. And so I can see that this is written in vertex form because I have my x minus h plus k part right here that I know is a piece of vertex form. And so in order to start this process, I'm going to identify information I know from this picture. And just by looking at this equation here, I know that my vertex is the opposite here of h, which is 20, and then our k value, which is 10. So there's my vertex to start. So I'm going to pull that information out because if it's written in vertex form, I'm going to guess that that is important. Then from here, part A says to draw a sketch of this scenario and identify the axis of symmetry, vertex, x-intercepts, and y-intercepts. So I'm going to start this process by drawing a sketch. Now, I know that this is going to start on the ground. And if I think about how a ball flies through the air, I'm going to draw a little bit of a sketch here. I know that a ball is going to start on the ground. It's going to be kicked up to kind of a high vertex point, and then it's going to come back down to earth. So it's going to look something like this. And the key parts of this that I have to find are I have to find the x-intercepts and the y-intercept, which we can see this starting point right here is kind of working as an x-intercept and a y-intercept because it's the point 0, 0. Then we have a vertex point up here that we can find from the equation, which is 20, 10. So really all we have left to find are the axis of symmetry and the other x-intercept over here. So I got my vertex, which we already found is 20, 10 from the equation. Axis of symmetry I know is going to be at x equals 20 because that's the x value of our vertex. Our y-intercept, I can see I'm crossing the y-intercept when x is equal to 0. Now, if you were unsure, if you weren't sure where to find the y-intercept, remember that we can find our y-intercept by taking x is equal to 0. So if we weren't sure that it was really at 0, 0, you could take the equation and write y equals negative 0.025, and then do 0 minus 20. Notice I put 0 in for x. And then just calculate that out. So we have negative 0.025 times 0 minus 20, all in parentheses squared, plus 10. And if I do that, I find that y is also 0. So this confirms that when x is 0, y is 0, is in fact my y-intercept point. Now after this, I need to calculate my x-intercept points, which I can see one of them is here at 0, 0. But I'm not quite sure for a fact where the other one is. So we're going to actually work on solving that as well. So here we have our x-intercept, which is going to occur when y is equal to 0. So I'm going to put y equals 0 into my equation. So I have negative 0.025, parenthesis x minus 20 squared plus 10. And so I'm going to scroll down a little bit more so I can actually calculate that here. So I'm going to start by subtracting 10 from each side. So I have negative 10 is equal to negative 0.025 x minus 20 squared. I'm going to divide by that negative 0.025. So if I take negative 10 and divide it by negative 0.025, I end up with 400. Then to undo the squared, I need to square root both sides. If we test 400 out, the square root of 400 is a perfect square. So that's going to be plus or minus 20 is equal to x minus 20. And so then from here, we can add 20 to each side. So we end up with 20 plus or minus 20 is what is equal to x. And so if I actually split that up and calculate both, I have 20 plus 20, which gives me 40. And I have 20 minus 20, which gives me 0, which, if I think about that, that 0 makes sense because that's my 0, 0 here. And the 20 plus 20 is telling me that my other x-intercept is at 40, 0, which kind of makes sense. So this is going up, reaches a high point when x is equal to 20. We can see that here. And then it falls back down to the ground by 40, 0. So now that we've drawn this entire sketch and we can see our axis of symmetry, our vertex, and our x and y intercepts, we can actually move forward and now try to start solving and figuring out the answer to these other two questions. So question I'm going to start with first is, what is the maximum height the ball reaches? Now, we know that height is over here on the y-axis, and we know that the highest point we reach is right here at our vertex. And our height is going to be our y value here. So the maximum height the ball reaches is that 10 in the vertex. And so we would say that 10 feet is the highest that maximum, the highest point that soccer ball reaches. Then from here it says, how far away from the original position does the ball land? Well, we started here and we land over here. And we learned from finding our intercepts that this distance right here is 40. So what that's telling us is that the ball lands 40 feet away from us. So if we can draw a sketch of these word problems, we can identify quite a few pieces of information about them, about heights and lengths and those types of things.